Today on Engineering Newswire, brought to you by Interpower Corporation, the premier supplier of power system components with a 1-week manufacturing lead time and over 4 million parts in stock, we're flying bicycles, wearing augmented reality glasses in class, and setting aviation milestones with helicopters. Ford has developed a robotic test driving program to meet the demands that the company's trucks undergo ever more strenuous testing with greater frequency. Ford engineers have joined forces with Utah-based Autonomous Solutions to come up with software and components for robotic operation of a test vehicle. A robotic control module is installed in the test vehicle that controls vehicle steering, acceleration, and braking. Utilizing cameras in a central control room and a GPS that is accurate to plus or minus 1 inch, the system follows the test vehicle as the module propels it down a pre-programmed course. If the vehicle wanders off course, engineers can initiate course correction from their location, while the vehicle has onboard sensors that can command a full stop if a pedestrian or another vehicle strays into the path. So what's the big deal, right? I mean, Google has an automated vehicle as well. As a crash test vehicle, these trucks are expected to repeatedly perform tests on tortuous surfaces that compress 10 years of daily driving abuse into courses just a few hundred yards long. Until now, testing speeds and repetitions for specific scenarios were limited due to restrictions placed on human drivers, who were allowed to drive certain rigorous courses only once a day. Now, robots are not only accelerating the process, but also allow Ford to develop even more challenging durability tests to build tougher trucks.
The Associated Press recently reported on the successful test flight of a prototype electrical flying bicycle designed by 3 Czech companies, Technodat, Evector, and Dorotech, with the aid of 3D PLM software tools from Dassault Systems. The flying bike looks similar to a mountain bike, but features 2 battery-powered propellers in the front, 2 in the back, and 1 on each side. The 1,200mm diameter main propeller maxes out at 2,200 RPM, and the stabilization propeller in the back is surrounded by a composite casing. The frame of the bike is welded from a light alloy duralumin, giving it a combined weight of 209 pounds without a pilot. As you can see, it has already taken off successfully and landed after a 5-minute remote-controlled flight.
Eurocopter, a Franco-German-Spanish division of EADS, made aviation history with its X-3 helicopter flying 263 knots in a descending flight. Now, the hybrid copter reached another milestone speed of 255 knots in level flight, overtaking the previous record of 250. This is just another notch in the X-3's belt, as it is the demonstrator for an advanced, cost-effective vertical takeoff and landing transportation system that offers the speed of a turboprop-powered aircraft and the full flight capabilities of a helicopter. Soak that in for a second. Yeah, this is a beastly helicopter. The X-3 configuration utilizes a pair of RTM 322 turboshaft engines to power a 5-blade main rotor system with 2 propellers installed on these short-span fixed wings. The RTM 322 variant powering the X-3 is based on the RTM 322 powering the NH90, only it incorporates an FADEC that has been adapted for high-speed applications. The X-3 has accumulated a combined total of more than 140 hours in flight since fall of 2010. In reaching the latest 255 and 263 knot achievements, Eurocopter has confirmed the concept design's potential as the company looks to continue to break records and reach milestones.
The Augmented Lecture Feedback System, also known as ELF, is the latest project to come out of the UC3M Interactive Systems Group to improve communication between students and professors during large university lectures. Here's how it works. The professor wears a pair of augmented reality glasses that allows him to see the symbols above each student. Students use their cell phones to activate the symbols. Think a sim family when it's hungry or angry. This will tell the professor if they don't understand, to ask the professor to slow down, or to say whether or not they know the answer. Huh. If only we had a way to do this now. Huh, what's happening here? Oh, wait a second. Oh! The system will also show the teacher a graph based on the student's answers. Students will now have an immediate and private way to communicate with teachers without interrupting a class. And professors will have an immediate source of information on what is clicking with students. The hope is that this system will make for more effective lecture classes because receiving continuous feedback will allow professors to adapt based on the students' actual knowledge and understanding. So much for the old standby.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For PD&D TV, I'm Chris Fox, and this has been your Engineering Newswire.